Hey, what's going on, guys? Welcome back to the ElementalMaker. Today, I'm going to be showing you some of the trials and tribulations I've faced trying to make a nice, simple, characterized rocket motor that we can use for this nice little 3D printed rocket that I put together. You can see this is all 3D printed, so if you're playing along at home and you know what you're doing, you could try putting one of these together and launch it yourself. So, in order to actually launch this, I wanted to put together a motor we knew the exact characteristics of. So, this is kind of going to be a video showing the efforts and fails and all that crap going into this, because I thought it was just going to be simple, slap a motor together, drill it out, call it a day, and launch. It ended up being much more involved. I've tested about 30 motors to finally get to one I'm happy with, performance-wise. And I had nozzle erosion issues. You can still see I got a little bit of nozzle erosion there. But this is the final motor. I am happy with its performance. It ranks just above an Estes E-Class motor in terms of total impulse. So it's actually pretty powerful. I'll just jump right into it. You guys can see how I made this and some of the fails along the way. Hope you enjoy it. So I designed this sucker up in Fusion 360, you can see, and it's just going to be a simple sugar motor, no melting of the grain, none of that. It's just going to be all tamped into place, and then drill the core out, done. Now again, you could just do this with a belt sander. Just, you want to square the ends off nicely. You can probably see her jaws weren't all that gentle on the shaft. Couple little teeth marks. That's fine though. Not gonna hurt. Not gonna hurt it. Alright, there we go. One test grain. Just need to drill the core out and we're done. There we go. So one thing I'm going to be doing slightly different here is, in previous tests, I would just jam the E-match down into the heart of the motor. That would ignite, get shot out of the motor, ejected. The issue was a lot of times, especially with these kind of weaker clay nozzles, they would get damaged from the actual ejection of the E-match. So, instead of doing that, I'm going to use some quick fuse and jam that down into the motor. And then just tie the E-match to the quick fuse. That way, nothing super hard and abrasive is actually inside the motor, and this will light the entire grain in one quick shot. Whereas the E-match, it only starts right where the E-match ignites and then moves outward. This fuses so insanely fast that it'll light the whole core essentially at once. So we'll just tape the E-match to the fuse here and call that good. Just so you guys can see what the quick match actually looks like. Pretty fast stuff. All right, we got to move fast. There are nasty clouds moving in and lots of thunder. Alright guys, well, courtesy of the wife's laptop, we can see some pretty damn disappointing data. So, motor 1, which was the slightly lighter motor, had a thrust of 405 grams, roughly. Motor 2 had a thrust of 500 grams. Now, I don't think that difference is due to more propellant in one or the other. We were very, very even. I think that weight difference was just the PVC. What I think happened is the nozzle just started eroding sooner in motor 1. You can see I'll put the damn graphs up. The point exactly when the nozzle started eroding, and you can see the big dip out of the curve. So these motors did absolutely dog shit. You can see both these nozzles are just massive gapers at this point. Let's actually measure about where these are. Oh my god. So the original 4mm hole, and unfortunately that means this is not going to be flying today. Our rocket here. We need to do a little more refining, at least of the nozzle composition. I actually already put in an order with the company for some fire clay. I'm going to try a new nozzle recipe with a proper refractory clay. So hopefully this will have much less erosion in our next go round. Today I was supposed to be editing my video of my new motor design for you guys that I was going to try to characterize, make a very repeatable, excellent motor with just standard 6535 potassium nitrate sucrose. But just like the beautiful lady down at the local ballerina who does the cool trick with the ping pong balls, these motors are kind of gay. What should have been a nice, super easy to make motor has now become overcomplicated because I need to rethink my nozzle composition. This cheap bentonite clay and wax mixture just is not holding up. I think I also had a little bit of grog in here, which is just basically really crushed like ceramic. You could make grog out of any crushed ceramic. It looks like this. It's basically ceramic sand, and what that does, it helps bite into the walls of the PVC, prevent the nozzle from pushing out under all that pressure. So what I have to fix the issue is fresh from the mailbox, some fire clay, which should hold up to the high temperatures of a rocket nozzle much better than, you know, the kitty litter bentonite. At least that's my hope and theory. We're going to use a mix of fire clay, grog, and some paraffin wax that we're going to melt in. Hopefully with these we can create a much better nozzle that doesn't just completely obliterate itself in the face of a little pressure. So what we're doing is a 60-30-10 of fire clay to grog to paraffin. That should give us a nice tampable or pressable composition that hopefully is going to be extremely resilient to the high temperatures and pressures that a rocket nozzle has to endure. So let's mix this up, throw it in the oven, get it all mixed, and then see how the heck it does. Oh, good move. Always like a pro. All right, got the oven set for 200. Just going to throw that in there for about half an hour. Fresh out of the oven, and it's already pretty well mixed. I gave it a few stirs throughout the process. There we go. Obviously, if you're doing a larger batch, you'd need longer than half an hour, but since this is only a 100-gram batch, half an hour seems just about fine. All right, ready for our second go-round with an improved nozzle hopefully improved nozzle composition. We'll see how it holds up. Hopefully we'll get some good data. All right, guys, so we did get much better numbers from these. So this one produced over 1 kilogram. You can see it just broke the 1,000 mark a few times there throughout the thrust curve. And the second one actually hit about 1.2 kilograms. So pretty good thrust output for 32 grams of propellant. And our ISPs, not horrific. We got 46, which is kind of mediocre, and 38, which is not all that great. Better than before, but I also think I miscalculated the propellant last time. So Ignore the last ISPs. That being said, we had worse nozzle erosion here. I think they may have held up longer before they started deteriorating, but I mean, Jesus. I mean, these things look over a centimeter. Yeah, we're at like 1.1, oh man, 10.5, right around there. This one's a little better at, oh, never mind, 10.7. So major nozzle erosion on these, although they did produce a better result. So I think this fire clay actually held up a little bit longer before it gave up, and that's why we were able to generate better thrust. It's kind of interesting how you can see the spikes at the end of both these. So I'm wondering if that's where the nozzle started eroding. Now, two things I think are causing this. One, the nozzle might be a little too thin. We might just need to add an extra 5 millimeters or so of nozzle material there, and it should fare a little better. Issue number two, I just looked at a cross section of Estes rockets, which should have similar performance. They're black powder. This is KNSU, which should be reasonably similar. They only extend the core into their motors maybe to about there. So they get a high initial thrust, and then it becomes essentially an end burner, and it just gets a longer sustained burn. So I'm thinking we should try that. Let's try a shorter coring, so maybe we'll go in 25, 30 millimeters. Yeah, that seemed a little on the weak side. Alright, so we made a max of 591 grams of thrust, which wasn't too bad for how asthmatic the motor looked, but we still got some nozzle erosion. Not nearly as much this time, so a little better controlled. But yeah, pretty disappointing. So I think we need to go with the larger end plug, larger nozzle plug rather, and keep the core pretty long. Alright, I think we're up to like test 30. So what I've tried doing is I created a convergent section to actually press our nozzles, which of course, and I also increased the length of the nozzle section as well. Hopefully that'll result in the throat diameter staying a little more consistent throughout the burn, along with the convergent section hopefully helping the gases flow instead of being super turbulent in there. And I've kept the grain size approximately the same. We're going to have that little bit of extra grain size with the little convergent area there, but we still should have right around a 30 or so gram, what was it? Yeah, so somewhere around like a 32 gram nozzle or a propellant grain. Now the thing is that kind of pushed the back of the motor into the aft section, so a little less room here for the actual ejection charge, but should still be enough. Hopefully I don't have to modify the 3D print files for the actual tail section again. But if so, it's not a big deal. I already have everything else printed. I could just reprint a longer tail section and be good. Although that is epoxied in. That's a problem. Let's go try it. See how she spits. Let's see how she does. This is with the new convergence section, longer nozzle as well. There we go. Alright guys, finally we have a motor that I'm confident in actually using to launch this puppy. So, you can see here, beautiful thrust curve, very, very similar to an Estes motor actually. You can see we have an initial spike up to 1,652 grams, 1.6 kilograms, and then it settles out right around 1 kilogram of thrust. Total impulse 13, so that's actually above, at least according to Estes charts, that's slightly above an E, which is pretty darn impressive. I wasn't expecting it to get into that range. An ISP of 41, just assuming 32 grams of propellant total. I think we are good to actually put together a motor with a proper delay grain, give that a quick test, and then we can fire the rocket. I still got to build a parachute. That's another thing. Pretty freaking cool though. Thank you so much for watching, guys. I hope you enjoyed. Also, if you're interested in building one of these, I'll leave a link to the video down below. You guys can check it out if you haven't already. I built this some time ago, back when I didn't have nearly as many subscribers, and I get questions constantly about it every time I use it in a video. I'll put a link in the description. Check it out. See how I built this. It's all Arduino code. Uses the HX711 board, a nice 50 kilogram load cell, a little 5-volt relay, and an LCD keypad shield over your Arduino. Super simple to put together, and works like a charm. I should really put it in some sort of enclosure. So, hope you guys enjoyed. Thank you so much for watching. If you like what you see on the channel and want to help me continue making videos, please consider supporting the channel on Patreon. That way I can keep these videos rolling, keep buying supplies. I know you guys only see a quick 10-minute video, but the amount of work that went into this one specifically, I had so many freaking motor failures. It is unbelievable getting up to this point of just finding out a way to build a nice reliable motor. You can see we still had a little bit of nozzle erosion. Well, a pretty fair bit actually. But at this point we have a beautiful thrust curve. I'm not going to question it. So, thank you so much for watching. I'll see you guys next time. Have a great one.